In this video I'm going to introduce factoring, and more specifically we're going to begin factoring out the GCF, or the greatest common factor. First though, before we talk about factoring out the GCF, let's talk about what factoring is. So far with polynomials you've used the distributive property to replace a product like 3 times the quantity x plus 2 with the sum 3x plus 6. With factoring we go the other way around. You'll start with the sum and rewrite it as a product. So distribution goes from a product to a sum, and factoring goes from a sum to a product. Now with distribution there's a single idea that allows you to do the problems that we've had so far. Unfortunately with factoring there isn't a single idea. There's a set of ideas that we use depending on the kind of polynomial we're starting with. In this video we're going to concentrate on just the first idea, which is factoring out the GCF. The first thing we have to talk about is how do you find the greatest common factor? And the idea will be that if it's necessary, you'll prime factor any terms that you can't see the prime factorization, and then you look at each of the prime factorizations and you find the product of the factors that all of the terms share. For instance, if we're going to find the GCF of 4y and 12, we'd want to see 4y as a couple factors of 2 and one factor of y, and then 12 would be a couple factors of 2 and one factor of 3. And again, our idea now is what's the greatest common factor? You'll notice both of them share one factor of 2 and a second factor of 2. And that makes the greatest common factor a 4. Try this one. The prime factorization for 18y would be 2 times 3 times 3 times y, and for 24 it would be 2 times 2 times 2 times 3. To find the factors they both share, we'd notice they both share a 2 and a 3. And that makes the greatest common factor a 6. Here's another one. In this case, 8k will be 3 factors of 2 and one factor of k. 32 will be 5 factors of 2. You can see they share 1, 2, 3 factors of 2. That means the GCF is 8. Once you can find the greatest common factor, then we concentrate on factoring it out. Here's the steps. You identify the GCF, then either in your mind or on paper you rewrite each term as a product of 2 factors. One of the factors is the GCF, and the other factor is everything that isn't the GCF. And then we factor out the GCF. I'll do this first one using a problem we just saw a couple minutes ago. The first thing I have to do is figure out the GCF, and as we saw, that's going to be a factor of 4. Now I go to my original polynomial and I think of each term as a product where one of the factors is 4. For the first term it's going to be 4 times y. For the second it's going to be 4 times 3. Now I factor out the 4, that is, I write a single factor of 4, and then I build a set of parentheses, and in the parentheses I put everything that isn't the 4. That is, I put the y plus the 3. This is now the factored form of 4y plus 12. To verify my work, I can distribute, and we usually just do this in our head. This will be 4y plus 12 That matches my original polynomial, so I feel that my factored form is correct. Here's one for you to try. In this problem, our GCF is going to be 3. The first factor is going to be 3 times x, and the second 3 times 2. First, I'll factor out the GCF of 3 and build myself a set of parentheses. And in the parentheses, I'll put the x and the plus and the 2. If I distribute in my mind, I can see this is 3x plus 6. And that matches my original polynomial, so I feel good about my factored form. And here's the last one. Since 15 has factors 3 and 5, the GCF is going to be 3. The first factor will be 3 times k, and the second 3 times 5. I'll factor out the 3, and in my parentheses, I'll put the k minus 5. If I distribute, I'll get 3k minus 15, which is a good check on my work. Well, that concludes this first video where I've introduced factoring and we've practiced factoring out the GCF.